Hey guys, we are going to be beginning Unit 4 today. And Unit 4 comprises of indicators 12, 13, and 14. All right, so indicator 12 is all about areas and formulas for triangles and other quadrilaterals besides your trapezoid. We are going to do trapezoid in indicator 13. That's a separate indicator all on its own. Okay. So before we go into your area of triangles and stuff, I just want to make sure that you remember the different triangles and what are quadrilaterals, so that you know exactly what the question is asking you. Okay. So we know that these are all polygons. They are two-dimensional shapes, and we are going to go ahead and start with a polygon that has the smallest number of sides. Okay, so which would be a triangle. So when we talk about a triangle, we have several types of triangles. All right, we have equilateral triangle. So if I say equilateral, you know that just by looking at the word equal in there, just look at the word equal in there. This has 3 congruent sides and 3 congruent angles. Congruent means exactly alike, exactly the same, identical. Okay, so we have 3 angles. Since the internal angles in a triangle always measure up to 180 degrees. Okay, so therefore this is going to be 60 degrees, 60 degrees, and 60 degrees, because they are absolutely the same. That's why they're congruent. So that is the word you got to know, congruent. And in an equilateral triangle, all the sides are also congruent. It's exactly the same measure. Okay, so that's an equilateral triangle. Then let's look at an isosceles triangle. Okay, so in an isosceles triangle, it has 2 congruent sides and 2 congruent angles. Okay, so if I make an isosceles triangle like this, all right, so these 2 angles will be congruent, or any 2 angles are congruent, and 2 sides are congruent. One will be different. But again, the internal measure of all triangles is always 180 degrees. So inside, when you, if you are given values and you were supposed to find out the missing value, you just know that internal angles of a triangle measure up to be 180 degrees. Okay. The next type that we will talk about is a scalene triangle. So scalene triangle has no congruent sides, no congruent angles. So that would be a scalene triangle. Okay, everything is measuring different angles, different side measurements. So this is a scalene triangle, no congruent sides. Okay, so each side definitely must have a different length on this one. Okay, the next thing we're going to talk about is a right triangle. Okay, and in a right triangle, one of the angles will be 90 degrees. Okay, so one of the angles will be 90 degrees. Okay, so here we go. So 90 degrees is always shown like this. It's 90 degrees over here. Okay, so one of the angles is 90 degrees. All right, then the next kind, the last 2 types of triangles that we'll discuss are an acute triangle and an obtuse triangle. All right, so an acute triangle and an obtuse triangle. Okay, so acute triangle has 3 acute angles. So that means an acute angle is an angle that measures less than 90 degrees. So it's small. So I always say acute is normally small. And so therefore acute triangles, you know, so each of these is going to, if you take this angle, these are all going to be less than 90 degrees. Okay, so this could be something like 82 degrees, for example. All right, you could have 61 degrees, 37 degrees. So that's basically, what you're seeing, that these are equal to 180. And then you also know that acute triangles are definitely going to be less than 90 degrees, each of them. If I add these up, I should end up with 180 degrees. Okay, so in an obtuse triangle now, we have one angle which will be greater than 90 degrees. Okay, so if I had a triangle like this, so look, this is definitely greater than 90 degrees. 90 degrees is like this is going like this, all right? So therefore this is greater than 90 degrees. This is an obtuse triangle, all right? So these are different types of triangles. And when we get to the area of a triangle, we'll talk about this. In this unit, you have got to know the formulas now, okay? So we'll get to area of a triangle. You have base times height divided by 2, or you can also write it as half base times height. So that is the same thing, okay? So half base times height. We'll talk about this in a minute. Let's quickly talk about the different quadrilaterals. All right. So whenever I say quadrilateral, immediately students just say square. But square is just one type of quadrilateral. Okay, there are several types of quadrilaterals. When I say quadro, the quadro means 4. So quadrilateral is a polygon, a 2-dimensional shape, which has 4 different sides. Okay, so we have square, you have rectangle, you have parallelogram, you have trapezoid, you have rhombus, okay, so we're going to deal with these right now. So square is obviously a shape where all 4 sides and all 4 angles are congruent. Okay, so all 4 sides and all 4 angles are congruent. So if I draw this out, okay, so all these sides will be congruent, and obviously each of these is 90 degrees. This is 90 degrees, 90, 90. So the internal angle of any quadrilateral is always going to be, remember the triangle was 180. So this will be 180 times 2, which is 360 degrees, because 90 plus 90 plus 90 plus 90, or 90 times 4, is going to give me 360. Okay? All right, I can't even see the video. There we go. All right. Now, so that is a square. And then let's look at a rectangle. In a rectangle, the opposite sides, of course, in all of these are parallel to each other. Same thing, they're parallel. But this and this will be congruent, and this will be congruent with this. These opposite sides will have the same length. Angles are all 90 degrees. So you end up with 360 degrees. All quadrilaterals have the internal angles measuring up to 360 degrees, okay? Parallelogram, you'll have two slanting like this. So these two are going to be congruent to each other, and these two will be congruent to each other. Okay, but this is a parallelogram. And this is the base of a parallelogram. Height in any slanting measure is always taken as the dotted line, because when we get to the area in a minute. Okay? And then we have a trapezoid, which has two bases of different measures. Okay? And then this is, of course, the height. But you have a big base, you have a little base, because if I flip it over, it becomes, the little base becomes the base. So, and then you have, this is a trapezoid. And then a rhombus looks like a kite. Okay, it looks like a kite over here. So these are the different quadrilaterals. Just wanted to review this with you. And then a shape with a polygon with 5 sides is a pentagon. All right. Then you have 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon, and so on. All right. Math is like unlimited, believe me. Okay. So let's go ahead now talk about the learning target. I can evaluate expressions and formulas. So right now, I was just, showing you the different types of, the triangles and the quadrilaterals. Let's talk about how we're going to solve when we have the formulas, which we've got to know. And it's like, let me start with the quadrilaterals actually, since it's already up here. All right. So if it's a square, area is, if I take this as an S, now we know it's a square. So every side has to be the same. If S is given to you, you know that for area, all I have to do is S times this size, S. So like normally in triangle, we say length times width, but in in a rectangle, we say length times width, but in a square, basically, all your quadrilaterals are length times width, or base times height, or this times this. So it's pretty simple. Now here, because it's a square, all sides are the same. Instead of saying S times S, we can also write it as S squared. Okay, and I'm going to show you why we have that formula in a minute. Okay, so in this case, if I said one side of the square is 7 inches, what would the area of the square be? Please do not do 7 times 4, because that will give you the perimeter. Perimeter is the distance around a shape. We are talking about area. The number of square units inside a shape is called area, is the number of square units inside a shape. And I'm going to show you a quick demo in a minute as to why we are saying square units, okay? And so if one side is 7, the area of this shape is going to be 7 squared, which is 7 times 7. So 49 inches squared. Please do not put the exponent after 49. Otherwise, it will be completely incorrect. Because if you put the square, you've done exponents, and if you put the square over the 49, it would mean 49 times 49 would be the answer. So it would be totally incorrect. In all of area units, the square units are always put behind the unit, the exponent part. You can also write it as 49 square inches. So this could also be an answer. So either this or you're solving it like this. Okay? For area of a rectangle, your formula is length times width. Okay? So if I say this is 8 feet and this is 2 feet, what would the area be? Just take the length, multiply it with the width, and you do 8 times 2, and your area is 16 feet squared. Or you can write the square like this, feet. Okay, so this is how we calculate the area of a rectangle. This is a parallelogram. Okay, so this has a base. Always look at the slanting line for the height. So let's say I give you that the base is 5 inches and the height is 3 inches. So area of a parallelogram is base times height. Okay, and so all we're doing is 5 times 3, and I get 15 inches squared. So this is the area of a parallelogram. Okay, rhombus we do not require for this standard, so I'm going to remove this. A trapezoid also is in the next indicator, so I'm going to remove this. Okay, now for area of a triangle, you've got to know these three for this indicator, and then the triangle. Okay, so let me show you something. And this always gives students an aha moment every year. They get so excited when they see this, okay? Because finally it dawns on them as to why we have this area formula for a triangle, okay? So, remember we said that every quadrilateral, it's either length times width, or it's base times height, or it's going to be side times side. But literally you're just multiplying, the base times the height, or you're doing the length times the width, or the side times the side. Now let's look at what happens. Let's say I had a rectangle, or any quadrilateral for that matter. Okay, let's say this was base times height or length times width, whatever you've written, it's the same concept. Now if I take any rectangle, any quadrilateral, and I break it into two, all right, you can see now I have two triangles. So what am I doing? The area of a rectangle or a quadrilateral, like let's say a parallelogram, is actually base times height, right? But now look, when I break it apart, I get two triangles within that quadrilateral. So that is why I divide by 2. Okay, because in every quadrilateral, I have two triangles. So because of that, the area of any quadrilateral divided by 2 is actually the area of a triangle. Or I could say a triangle is half the base times height, because base times height is a quadrilateral. Divided by 2, or half of the base times height, gives me the area of a triangle, because this is half of this is half of this. Okay, so if that makes sense. So if I had a triangle, let's say I take any triangle and my base is 7 okay, 7 inches squared, sorry, 7 inches, because that is a side. And then height is always given like this. Okay, if they give you a measurement on the sloping or the slant of the triangle, please do not use that for the height. The height is always signified by the straight line that goes up and down. Think about it. When you yourself go to your pediatrician and they take your height, you are standing straight up, okay, on that scale. You are not going like this in a slant, okay? So that is why height is always going straight up and down, okay? So let's say the height is 5 inches. So the area of this triangle would be base, which is 7, times, well, let me just give you one. You would get a decimal in this case. So that is why I'm just going to change this, because I don't want to do that right now. Okay, so let me do 10. Okay, so 7 times 10, and that is my base times height. Now, very often children make this mistake. They do the 7 times 10, but they forget to divide by 2. Okay, now please remember, over here, of course, it's not drawn to scale, but I'm just saying, all right? Now, remember, this is a fraction, so I can simplify before I multiply. So this is times 1 and times 5, because 5 times 2 gives me 10. So 7 times 5 is 35 inches squared. All area will be in square units, okay? Now, let me correlate the formula of the, the quadrilaterals or whatever is given to you based on what we do in the classroom. So I am going to walk you to my smartboard where I have pulled up something which my students do every year and you will find it in my classroom. Okay, so I hope you can see that clearly. Trying to prevent the glare. Okay. So let's say you are asked, because area can be, it doesn't just have to be like one thing. It's basically the factors. So in this case, let's see, 1, 2, 3, 4 times 1, 2, 3, 4, 5, 6, 7. Okay. So in this case, what are we doing? If you take the length times width, we have 4 times 7, and so you get 28 inches squared. But look what is inside. These are all square units. So the formula is there to make your life a lot easier. Otherwise, imagine trying to find area of the entire country. Imagine trying to go around the country trying to count up all the square units inside. So because this is what it is. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So literally you have 28 of these little square units inside. So it's said to find area with 28 square units, and I gave them the choice of they could construct it anyway. All right, as long as, of course, it was a regular polygon. So in this case, they have 28 square tiles in there. And so if you took the length times width, you would have just done 4 times 7, which is 28 straight out. So that is actually the area formula. Okay, so let's look at this one. This child did, if you did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And there are 2 layers of that. So 14 plus 14 and got 28. Because we are all, in this case, trying to find how can we get 28 as the square, the area, okay, of the rectangle. So we're taking factors of 28. You could have done 4 times 7, like this child, you would get 28. Here, this was 2 times 14. So again 28. Or you are putting 28 of these square units straight up. So you are doing 1 times 28. But that will also give you the same thing. So I just want to show you the correlation between the formula and why it is, instead of counting all those things, why we have a formula. Because formula is making your life a lot easier rather than just imagine going around the United States and trying to find the entire area of the country by counting square units. My gosh. So to prevent all this, the area makes life, the formulas make your life a lot simpler. Okay? So anyways, these are the different, of course, triangle, or you have the quadrilaterals. You've got to know the formulas in this one. Okay, because it will not be provided to you. You will have to know these formulas. Please remember what I said, that in any quadrilateral, you have two triangles. And so that is why you have base times height and divided by 2. Or each triangle is half of the base times height. So that becomes the area of a triangle. And all you're doing then, you'll be given a length, you'll be given a width, or you'll be given the base, height, and you have to substitute the values and solve it that way into the formula. All right. Have a nice day, guys.